Alright guys, last time I gave you this problem where I said, what is the average dice roll? If you just take a single six-sided die and roll it, what's the average outcome? And there are many ways you could find that. You could think, well, let me just do 1 plus 2 plus 3. Just do all the possibilities. And then divide by 6. And if you did that, you would get 21 divided by 6, which is 3.5, if I could type that. And you might think, maybe that's right. I mean, that seems to be what you need, but it looks a little weird. I would expect an integer, wouldn't the average be 3 or 4 or something? And if you're really clever, if you're really on the ball, you might think, I don't even need the ones in the middle. Maybe I can just do the top and bottom, divide by 2, and you still get the same answer because you're finding the middle of that range, right? If you are in the mood, if you're the type of person who likes to really minimize and make it efficient, you might go for that. And that will get you an interesting answer. But let's say you're not sure. Let's say you have a scientific method in mind where you want to test it. You want to say, well, that looks nice, but let's actually roll some dice, or let's simulate actually rolling some dice, because we're not going to do it 1,000 times and take all day. We're going to have the computer do it. So what I did last time was said, well, let's have a computer make a list. Just get a random number 100 times and then show it. And then we'll take the total of that divided by how many. So if I run that, it gives us a pretty good sample. This time it was 3.61. So not exactly our 3.5, but it's around there. And if you do it, it'll often be 3 point something. Okay, I've seen it get down to 3.2. I've seen it get up to 3.8. Usually it's 3 point something. Oh, there's a 3.9. That's the highest I've seen, but it's bouncing around in that area. Okay, and you might say, well, let's just do more. Okay, if you rolled 2 dice, for example, it could be really high or really low. But if you rolled 1,000,000 dice, you would, in theory, be getting closer to the true answer. And if it turned out to be 3.5, then you could really support our initial guess, right? So what I said last time was, what if we did this whole thing a bunch of times? We rolled 100, found the average, and then rolled another 100, found the average, rolled another 100, found the average. And then we take the average of those averages. Now, is that the only way to do it? Of course not. We could just add more zeros in here and have it roll the zillion. But it's kind of nice to see these partial results, to see that, hey, this one was a 3.9, and the next one was a 3.4, and the next one was a 3.6, and to kind of see the variety instead of getting one giant pile and one answer out of it. Sort of like if you're doing a survey and you get the results for Indiana and the results for Kentucky and the results for New York, and you see all of those, then you can see a total as well, but it's nice to see the different ones. So let's imagine we want to do this whole thing 100 times. And what I mentioned in the last video, and the whole reason we're doing this, is that there's more than one way. There are, in fact, a lot of ways. that you might do that. Computer science should not be going to a tutorial and copying the code. It should not be trying to get the right answer. It should be using a little bit of creativity and a little bit of thought. And whenever somebody looks at your code, they can see your style and they can go, oh, he did it this way, she did it this way. And one person has a more statistical mind, and one person has a more language mind, one person has a more logic mind, and that's okay that they're all working the problem in a way that works. And we get to see these interesting differences. So, for example, one thing you might do is just go, boom, I'm going to make a big loop around the whole thing. Maybe I'll say for j in range 100, which means it'll do this whole thing 100 times. And then somewhere along the way, I'll add a new variable that keeps the averages. All right, like average list, and then okay, so we're keeping a list of the averages, and every time we find one, we add it to the total, and then when we're done, we can find the average of averages, which is basically this, like doing this same thing. We're going to say average of averages equals, and then how are we going to do that? Well, we got to find the total, and honestly, I don't want to type that, because I don't want to type, okay, finding a total, and then dividing it by the amount, and then, because I've already done this. I've already told the computer how to find an average of things, and I don't want to do it again with different words. So this first approach, where you just wrap it in another loop and do another average, make another name, that's fine, but I don't want to type all that. I don't want to make it longer and uglier and harder to read by just doing more stuff, okay? So if you tried that, there's no problem. You'll get, quote unquote, the right answer. But it's not what I would try as like a perfect, beautiful final draft. It's something I would try first, and then I would think, let's do something else. What my instinct is we're going to have this guy, and maybe this guy too, reused, because adding up the total of the averages and dividing it by the average of the averages is the same as what we did with the dice. And I don't want to do all that again, so maybe we can say, hey, here's a function that tells you how to find the average of whatever. And we can use that for the dice, and then we can use that for the bigger outer layer. Okay, so let's do that. I want to do something. In fact, I'm going to hit Control Z to undo my indent, if it can go back that far. Oh yeah. So let's say I want to make this thing reusable. I want to be able to say, hey, you found the average of this chunk, now find the average of another thing with the same process. So let's say def find average, maybe, and not find average of a specific group, of a specific amount, of a specific kind of thing, but find the average of whatever. Okay, So let's send it, I'm just going to call this population, but we could send it anything, and we can call it anything. When you do that, we want to make these variables a little more general. So I'm going to say item in population. Therefore, it doesn't just apply to dice, it applies to anything. And then we divide by ln of population. So now this function can find the average of anything, of any size, at least if it's a list. Right now we're kind of treating it as a list. Or this would work for other things too, actually. This would work for tuples, or this would work for whatever. But there is a thing in Python that's relatively new. It was only added a couple versions ago, where if you want, you can give a hint about what you need in a parameter. You can say colon list, and that doesn't do anything, but it just tells the person glancing at it that, hey, this is supposed to be a list. And that's nice. Why not? Turns out, looking at the code, it probably would work for other things. So let's say we want to find the average of the dice list, because that's one thing. And let's hit run, because I think if I did this right, it's going to do exactly the same job as before, but it's going to have this ready to be reused later. Yeah, okay. 3.6, 3.5, 3.5, 3.2, that's pretty low. So now let's say we want to use this in another round by finding the average of these guys. I'm probably gonna make that into a function too. And then now that I've got this set up and I can roll some dice, I might as well make this more versatile. Instead of rolling exactly 100, let's say it can roll however much you want. Maybe I want to do 50 next time, or 1 billion next time. So I'm going to give this a parameter. I'm going to call this sample size, because that's often what you call it in statistics or survey, whatever. So let's say I'm going to give it a sample size, and then it's going to roll however many I want. It doesn't have to be 100. It could be 2. So now I'm going to roll dice. $100, and maybe it's going to return this so that we have we can spit it back out to whoever's asking for it. So I can say and then yeah. And then now that I'm making functions, I might as well call this one main and bump this one over and then run main. Let's try that. Does the same job. 3.2, 3.4, 3.3, 3.4. They're all hanging out on the low end. But we saw that it did get up to 3.9, which is why, like I said, we're not quite there yet. We're not quite like hovering around some really clear answer. If it was saying 3.30000 every time, then we would be like, oh, the average is 3.3. It must be really nailed down. But it's not. Okay. But here's the thing. Now that we have this a little more locked in, I'm going to squish these together just to make it fit on the screen. And now that we have these reusable chunks, versatile, This can work for any amount. This can work for the average of any list. Now we can use them to do this thing we wanted to do without typing the code again. Earlier, when I was saying let's find the average of the averages, I would have had to say, okay, we're going to make a list. We're going to put the stuff in the list. We're going to send that list to a couple lines that add it up, count how many, divide it, spit out an answer, print it, blah, blah, blah. But now we don't have to do that because we already have a function that can do that for anything. So we just have to say, hey, take these averages and send them to this guy that's already been doing its job, and it can do its job one more time, easily. So again, I'm not saying this is like the right way. This is just a way that I think looks good, a way that I think is versatile and usable and sort of ready for whatever you want to do. If you want to make it do a different amount or different calculation, it could. So let's say we want to, every time we get this average, we want to add that to some kind of list. Okay. So let's start off with average list, maybe. And then whenever we get this part, we can add, no, we can add this. We can say whenever we run this, it's going to spit out our answer with the return, and then we'll add it to this. Which means this line is doing a lot, and it's going to be our longest line. And I might even scooch over my frame border over here. But it's not like I had to type 5 new things in here. I just had to assemble things that we already prepped, you know. I know I've said this before, but it's often like in a cooking show, by the end, when you have everything cleaned and sliced and prepped, then the chef is just like picking up a container of carrots, throwing it in the pan, picking up a container of peppers, throwing it in the pan. And it looks so easy, but the hard part was earlier when you had to select it, slice it in the right shape and get the right amount and maybe peel the stuff or defrost something. So once you've got all this set up and you just say, hey, add, find, list, and it's like, oh, we prepped that, we know what that is. And it works. So let's say this thing, these 2 steps are going to happen a couple times. And then we just have to do one more thing at the end, which is find average of average list. And I think it's going to print it, and we don't have to do anything with the return. Maybe. Let's see what happens. If I did this right, I'm going to hit return. I'm going to hit run, and it's going to do this 100 times, and then show the average of the averages. Okay. Yeah, 3.47, and if I scroll up, I can see all the 100 times it did it. And maybe at the end, we want to say something to show that this is the real one. This is the big one. This is the special one. But you can tell it's different because it's a long float. It's not being rounded the same way. And if we wanted to look closer, we could figure out why it's not being rounded the same way. but that's an interesting quirk. 3.48, 3.49, 3.52. You can see it's really tightening up. It's hovering around 3.5, and it's never going to go 3.2, 3.9 like it was before. These answers are never straying by more than 0.02. So it's really higher resolution, really faster getting to the answer than like just hoping, oh, that one's off, that one's way off, that one's way high, that one just happens to be close. And this is something you can do when you are thinking about samples and statistics is, hey, why don't we do a lot? But the point of this, again, is not to say, hey, you should type exactly what I type. There's nothing special about what I type. You can do it differently with different names, and that's fine. But the idea is, when I'm doing something that I have to arrange and make a slightly bigger project, I do want to think about the future and make it easy on myself. 5 minutes from now, if I were having to find the average twice in 2 different ways, and then I decided to change the way it works, I would have to change both and hope I do it right and hope I don't have mistakes. But if I set it up once and reuse it, then we know it's going to work the same both times for sure. All right.